So, as I said to you previously, in the second method we can't utilize only atoms. We need to use ions or particles, yes, or atoms if they stand alone, like metallic zinc, yes. Okay, so oxidation oxidation reaction, metallic zinc to metallic, and you could see that here we have a more complex problem. So metallic zinc is, okay, once again, the metallic zinc is oxidized and zinc then exists in the anion, in the zincate anion. Yes, let's consider this one. In the water solution, this compound dissociates into two sodium ions and one zincate anion. The charge of this anion is equal to -2 because we have two oxygen atoms which give us -4 oxidation state and one atom of zinc which give us +2. The overall charge of this zincate anion is equal to -2. So okay, so we have zinc on the left and zincate anion on the right. Of course, there are two electrons. It's oxidation reaction, yes. So this zinc atom in the metallic form lose these two electrons. Okay, so we need to balance the mass, yes. On the left side there are no oxygen atoms. On the right side there are two oxygen atoms. You remember that this reaction proceeds in electrolyte, in aqueous electrolyte solution. We can pick up one of the three particles, H plus, water particle, and hydroxide anions. You remember that we use only two of them. In acidic solution, H plus and water particle. In alkaline solution, water particle and hydroxide anions. This solution is of course alkaline. We have sodium hydroxide solution, sodium hydroxide additive in this reaction. So we need to put water particle and hydroxide anions here. Okay, and you remember that in the side where are the electrons, we need to put the particle with the higher oxidation state, with the higher charge. The charge of the water as a neutral particle is equal to 0. The charge of the hydroxide anion is equal to -1. So here on this side we need to add the water, and here we need to add hydroxide anion. And now we can balance the mass and the charge. Yes, on the right side, what would be the charge? Yes, okay, on the right side, -2 plus -2 give us -4 plus 0 give us -4. Here, zinc, metallic zinc with the oxidation state equal to 0 and 1 hydroxide anion with the oxidation state equal to -1. So in the front of the hydroxide anion we need to put 4. We need to put 4. Okay, so the charge is balanced now. On the left side it is equal to -4. On the right side, it is equal also to minus 4. Okay, what about the mass? On the left side, there is one atom or 1 mole of zinc. On the right side, also. What about oxygen? On the left side, 4 atoms. On the right side, 3 atoms. So we need to put 2 in the front of water particle. What about the hydrogen? On the left side, 4 atoms of hydrogen. On the right side, also 4. So, okay, we accomplished the balance of charge and the balance of matter in the oxidation half-cell reaction. What about the reduction? What about the reduction? We said that nitrogen is reduced. Nitrogen in this reaction exists in the form of an ion, nitrate anion. I mean, of course, I am considering the left side, the substrate. In the products, nitrogen is contained in ammonia particle. Yes, we need to, of course, add, as I said, 8 electrons because here in this anion, nitrate anion, the oxidation state of nitrogen is equal to plus 5. Here in ammonia it is equal to minus 3. Okay, and of course we need to use the same two kind of particles, hydroxide ions and water particle. Please remember that on the side where are the electrons, we need to use the particle with the higher oxidation state, with the higher net charge. So we put here water. And here we are putting hydroxide anions. Okay, so what else? We need to balance the charge and we need to balance, of course, the mass. Yes. Okay. So please be aware that we can't, in such a situations, we can't change the coefficients of the particles where are the atoms that change their oxidation state. Because if we would like to put 2 here in the front of this anion, we should also put this number in the front of the ammonia. Yes, it's impossible because we need then also change the number of electrons. It will be 16. Yes, it's ridiculous now. It's ridiculous. Therefore, we can only change the atoms and particles number of the hydrogen as well as hydroxide particles. Yes? Okay. So, on the left side, the charge, we could start always, it depends on you. If you would like to start from the charge balance, you could start the charge balance. If you would like to start from the matter balance, do not hesitate, start with that. It depends on you, yes? I would like to prefer in this situation start with the charge balance, yes, because we are sure that this one and this one, I mean the number of electrons and the number of the nitrate anions will not change. So the net charge of the substrates, so on the left side of this half cell reaction, will be equal to 9. So we are sure now that on the right side also should be equal to minus 9. So we need to change the number of hydroxide anions. Yes? So we need to put here 9 hydroxide anions here. So we have, let's see, the net charge on the right side is equal to -9. The net charge of the left side is also equal to minus 9. -1 plus -8 give us -9. Okay, what about the balance of the matter? Let's see. On the right side we have 2 hydrogen. On the left side, on the right side we have 12 hydrogen atoms. So we need to put 6 in the front of water. On the right side we have 9 oxygen atoms, and on the left side we have also 9 oxygen atoms, 3 in the nitrate anion and 6 in the water in the 6 water particles. Okay, so in the oxidation reaction we have 2 electrons. 2 electrons take a part in the oxidation reaction. In the reduction reaction there are 8 electrons. So we have, in the oxidation reaction we have 4 atoms of metallic zinc. We have 16 hydroxide anions. We have one nitrate anion, yes, and that's all. And we get 4 zincate anions. We have also 8 particles of water, yes, 8 particles of water, and of course 8 electrons, yes. Here it's not overall reaction, so here we don't have a nitrate, yes, nitrate anion. Okay, 4 atoms of metallic zinc, 16 anions of hydroxide group, and we obtain 4 anions, zincate anions, sorry, 8 electrons which could be given to the anion of to the nitrate anion, and 8 particles of water. Okay, so let's write once again, for your convenience, once again the reduction reaction. Yes, so we have a nitrate anion plus 8 electrons give us, of course, plus here we have a of course water, yes, and we obtain ammonia plus hydroxide ions, 9 hydroxide ions, 9 hydroxide ions, and here we have 6 particles of water. Okay, so everything now seems to be okay. Okay, it's okay. So we could write now the overall reaction. So in the overall reaction we take the substrates and of course the products. We avoid electrons in an overall reaction. Yes, so overall reaction looks like that. 4 metallic zinc atoms plus 16 hydroxide anions plus 1 nitrate anion plus 6 particles of water. We obtain 4 zincate anions, 1 particle of ammonia, 8 particles of water and 9 hydroxide anions. Okay, let's let's see that on the right as well as left side of this reaction we have similar ingredients. I mean hydroxide ions here and here, water particles here and here. So we need to remove some of them. If we have 16 hydroxide ions here and 9 hydroxide ions here, we need to subtract this hydroxide anions. We need to remove all 9 hydroxide ions here from the right side of the reaction, so from the product, and we have to subtract from 16 the 9 hydroxide anions. So we get 7 hydroxide anions on the left side of the reaction. The same situation with water particles. On the left side we have 6 water particles. We need to remove all of them. On the right side we have 8 particles. If we will remove also 6, like on the left side, the 2 of them will remain on the right side, the 2 of them. Okay, so we have new overall reaction, I mean with new coefficients. 4 zinc atoms, metallic, 6 hydroxide anions, 1 nitrate anion, and that's all. On the right side, in the products, we have 4 zincate anions, one particle of ammonia, 2 particles of water, and that's all. And we can fill the coefficients of the redox reaction, which is presented on the top of the page. We have 4 zinc metallic 4 zinc metallic atoms. So we put the number 4 in the front of zinc. We have 7 hydroxide anions on the side of the substrate. 7 hydroxide anions tell us that we have 7 particles of sodium hydroxide. What else? We have 1 anion of nitrate. 1 nitrate anion. So we have 1 particle of sodium nitrate. Okay, so let's move to products. We have 4 zincate anions. So we have 4 particles of sodium zincate, 1 particle of ammonia, and of course 2 particles of water. Let's see if it is correct. On the left side 4 atoms of zinc, on the right side 4 atoms of zinc. On the left side 1 and 7 atoms of sodium give us 8 atoms of sodium. On the right side 4 particles of sodium zincate give us 8 atoms of sodium. Okay, what else? 3 atoms of oxygen in sodium nitrate, 7 atoms of oxygen in hydroxide give us 10 atoms of oxygen. In 4 particles of sodium zincate we have 8 atoms of oxygen and 2 atoms of oxygen in water particle give us 10 atoms of oxygen. What about the hydrogen? On the left side 7 atoms of hydrogen only in hydroxide. On the right side 3 atoms of hydrogen in ammonia and 4 atoms of hydrogen in water particle. So it's clear, it's correct. Okay, we made it. So let's solve another. Let's solve another example. The another example maybe some in some way different from this one. I will show you why.